Welcome to Scale Up University. Welcome to Power Plant Engineering course. So this is the lecture 1 of module 1, and in this lecture we will discuss role of electricity in modern society. So we'll start this course, that is a course on power plant engineering, with the first lecture of first module, that is role of electricity in modern society. So if we look at the topics we'll discuss in this lecture, so first we'll see why study electricity from an economic perspective. Then we'll look into electricity as the most versatile form of energy. Then we'll discuss characteristics of electrical energy. Then we'll move towards discussing electricity as a terminal energy form. Then we'll compare comparison of electricity with other energy carriers. And then we'll discuss strategic importance of electricity. And finally, we will conclude this lecture by discussing electricity as an indicator of economic development. So overall, this lecture will give you a very good feel and like importance of electricity. And that is what this lecture is, role of electricity in modern society. So all these topics we will cover one by one. So module 1 is economics of power generation. So in the module 1, we will be discussing economics of power generation. It is the lecture 1 of module 1, role of electricity in modern society. And we'll start with the first topic of this lecture, that is why study electricity from an economic perspective. So if we talk about electricity, electricity today is not just a form of energy, but the backbone of modern civilization. So if we talk about electricity, electricity is not just a form of energy, but it is the backbone of modern civilization. Like it has become so very much important in the modern society that it has become the backbone of modern civilization. And why we are telling so is because see, electricity. So every sector fundamentally depends on electricity, like industries, transportation. So you might be wondering that what is the role of electricity in transportation? Because transportation is about burning of petrol and diesel. But now you might have heard about electric vehicles. They are becoming very common. And this metro rail, bullet trains, all of that is powered by electricity. So in transportation also, now electricity is playing a very important role. Industries, like all the machineries in the industries, the driving force for it is electricity. In healthcare also, like all the hospitals, the testing facilities, the testing instruments, they are powered by electricity. Communication. So we are able to communicate, like transmit signals via towers because of electricity. So electricity is the enabling force. Even in agriculture, electricity is playing a role because electricity drives the water pump, because of which we are able to easily do the irrigation, and so many other like use cases are there wherein electricity is enabling, or it is the driving force behind agriculture. And most importantly, households. Just imagine how the life would be without electricity. So electricity is like very very important. So that's why we can say that, we can claim rather, every sector, like the list of sectors can go on. So every sector depends fundamentally on electricity, and that is the importance of electricity. So now we are getting a feel of importance of electricity. Now if we consider power plant engineering, because this course is about power plants only. So if we talk about, if we consider power plant engineering, So in power plant engineering, so what is a power plant? Power plant is basically a setup which can generate electricity. That is the power plant. So power plant is basically a setup, like a set of machineries, set of processes, operations, you through which we can generate electricity. So electricity is very much unique when it comes to the power plant engineering. So from the perspective of power plant, if we talk about electricity, from the perspective of power plant, if we talk about electricity, electricity must be generated continuously. So, like in a power plant, electricity must be generated continuously. And why is it so? Why there is a need to generate electricity continuously? It is because electricity cannot be economically stored in large quantities. So one drawback of electricity is that we cannot economically store it in large quantities. So the idea is that we have to keep on generating it continuously, and that is what power plant. So from the perspective of power plant, the idea is that electricity must be generated continuously because storing it economically in large quantity is not that feasible. And also the demand for electricity, it varies. So the demand varies like hourly, the demand varies on a daily basis, the demand varies seasonally, the demand varies annually. And power plant has to keep this in mind. Like power plant engineering is all about generating electricity. So electricity must be generated continuously, and it's a fact that the demand varies, and accordingly there should be a flexibility that how much electricity needs to be generated. So when the demand is more amount of energy should be generated, more amount of electricity should be generated. And one more very important point, the cost of generating electricity depends strongly on how it is generated and utilized. So the cost of electricity generation, it mainly depends on how we generate electricity. There are different ways of generating electricity, that all we will discuss in great detail in this course, because this course is all about power plants, means it's about generating electricity. So the way through which we generate electricity and the way we utilize electricity, it influences the cost of generation of electricity. So now, because see, this topic of this lecture is about why study electricity from an economic perspective. So now see, it's very clear that electricity is the backbone of modern civilization. Like without electricity, we cannot imagine our life. We cannot imagine modern civilization. So every sector depends fundamentally on electricity. So the importance of electricity is very much clear to us. And when it comes to generating electricity, there is a cost associated with generating electricity, and there is a need to optimize that cost, because if we can optimize that cost, because the demand for electricity is never ending, because economic perspective is all about balancing the demand and supply. So studying electricity from an economic perspective, the idea is to balance the demand and supply. So the demand will be evergreen, because the demand will be never ending. We will always be needing electricity. There will always be a huge demand for electricity. So the main goal is to have a constant supply of electricity. Electricity must be generated continuously. The demand varies, and it should be generated. It should consider those factors also. So the idea is optimization. We have to optimize the electricity generation. And that is what this course is about, power plant engineering, wherein we will be learning best practices through which we can optimize the electricity generation, and hence we will optimize the cost of electricity generation. Okay, now we'll look into the next topic of this lecture, that is electricity as the most versatile form of energy. So first, let us try to understand the meaning of versatility in energy systems. So what is the meaning of versatility in energy systems? An energy form is considered versatile if it can be used for multiple applications. So if an energy form can be used for multiple applications, then we say that energy form or that energy system to be versatile, easily transported. If we can very easily transport an energy form, we say it to be versatile. Efficiently controlled. If an energy form can be efficiently controlled, if we can control an energy form, we say it to be versatile. And converted into other useful forms. So if an energy form can be converted into other useful forms, we say it to be versatile. If we talk about electricity, so see, electricity is used for multiple applications, because we have already seen in the previous slide that electricity is the backbone of modern civilization, wherein electricity is powering the healthcare sector, agriculture sector, transportation, industries, even the households. So electricity has got wide range of applications, and hence electricity is versatile form of energy. Electricity can be very easily transported. If you talk about electricity, very easily you can transport it, and that is what we have been doing, because in the power plant we are generating the electricity, and there is a grid network is there, transmission lines through which we are transporting the electricity. So electricity can very easily be transported. We can very easily control the electricity. Electricity we can control, like we have step up transformers wherein we increase the voltage, and when we increase the voltage, electricity will decrease. And we have step down transformers. Basically, there are mechanisms through which we can control the flow of electricity. We can control that, okay, how much electricity is we should uh, flow in a wire, that we can very easily control. And electricity can be converted into other useful forms. So if we look into it, so electricity can be converted into mechanical energy. Now see, electricity can be converted into mechanical energy, and this mechanical energy is further used to drive motors, pumps, and compressors. Electricity can be converted into thermal energy, and that thermal energy is used in heaters, electric furnaces, induction heating. Electricity can be converted into light energy, and that light energy is further used in lighting systems, displays. Electricity can be converted into chemical energy, which is further used in electrolysis, wherein electricity is used to catalyze or to undergo a chemical reaction. Battery charging. So whenever we charge the battery, we have to supply electricity. So electricity can be converted into chemical energy, which can be used in the process of electrolysis, battery charging. Even electricity can be converted into information processing, and we can drive computers and communication systems. So here we can see that wide range of applications, we can get an idea about that. So no other energy offer such wide range of applications with such precision and efficiency. And hence, we are saying that electricity is the most versatile form of energy, because energy, like electricity, is used for multiple applications. It can be very easily transported, it can be efficiently controlled, and it can be converted into other useful forms. So, electricity is the most versatile form of energy. Okay, now we'll look into the next the topic of this lecture, that is characteristics of electrical energy. So if we talk about different characteristics of electricity, electrical energy, so the first characteristic is ease of generation. So electricity can be generated from almost every primary energy source like coal, oil, natural gas, nuclear fuels, water, that is the hydro, solar energy, wind energy, biomass. So electricity can be generated from almost every primary energy source. So if we talk about primary energy source, we have coal, oil, natural gas, nuclear fuels, water, that is the hydro, solar energy, wind energy, biomass. These are the primary energy source. And from all these primary energy source, very easily we can generate electricity. And this flexibility allows use of locally available resources. So the idea is that locally available resources very easily we can use to generate electricity. It also allows diversification of energy mix, and it allows improved energy security. So it's a very important aspect of electrical energy, that ease of generation. We can very easily generate electricity from almost every primary energy source. It allows us to use locally available resources, like in some place solar energy is very easily available, so we can make use of it to generate electricity. In some place there is a waterfall, or so some good water source is there, so we can make use of it to generate like hydroelectric power plants we can set up. Like we can generate electricity from fast flowing water. It also allows diversification of energy mix, because we can use different, like we can combine different techniques. We can combine different primary energy sources to generate electricity, and we will be also improving the energy security. So from an engineering point of view, we can say that any form of energy that can produce motion or heat, any form of energy that can produce motion or heat can ultimately generate electricity. So this is a very powerful aspect. Like any form of energy that can produce motion or heat can ultimately generate electricity. So ease of generation is a very important characteristic of electrical energy. Now, if we talk about the other characteristic, so we have ease of transmission. So electricity can be transmitted over long distances with relatively low losses. Electricity can be transmitted over long distances with relatively low losses. Now, if we look into some important points about transmission of electricity, transmission at high voltages reduce current. And what it is, see, the idea is that always remember, whenever we are transmitting constant power. Like what it is, I'll tell you. So see, you might be aware of this relation. Power is equals to, power means electric power, electrical power, it is equal to voltage into current. So the idea is that we always transmit constant power. Like see, the power is fixed. So if we increase the voltage, then definitely current will reduce. And if we decrease the voltage, current will increase. So it's a very important point I am making. So so in the transmission of electricity, this concept you should be aware of. So whenever we are transmitting electricity, like basically we are transmitting power. So we are transmitting constant power. So we can vary the voltage. If we increase the voltage at high voltage, current will decrease. And what benefit we will get? If the current will decrease, the losses will decrease, because that we will discuss now. low current reduces I square R losses, because see, we know what is the power loss, energy loss, that is I square R. So when the current will decrease, I square R, its value will decrease. So idea is that transmission at high voltage, if we transmit the electric current at very high voltages, it means we will be able to optimize the losses, we'll be able to reduce the losses, and that is what the main idea is. And we will be able to transmit electric power hundreds of kilometers. Power can be transmitted from generating stations to load centers. So we can transmit electricity hundreds of kilometers. It is possible, and it's possible like if we transmit at high voltages, because the I square R losses will be very low. It is feasible, and it's a very powerful aspect of electrical energy. No other energy like heat energy, we cannot transmit it to hundreds of kilometers, but electrical energy we can do it. So ease of transmission. So this enables location of power plants near fuel sources. So because of the ease of transmission of electrical energy, we can set up power plants. Power plants is the one wherein electricity will be generated. So we can set up power plants near fuel sources. So the idea is that then there will be no need for us to transport the fuel. Like fuel can be very easily transported to the power plant, and generated electricity can be transmitted hundreds of kilometers because of the ease of transmission. So ease of transmission enables us to set up power plants near fuel sources. It enables supply of electricity to distant urban and industrial areas. So this ease of transmission enables us to supply electricity to distant urban and industrial areas. It enables the development of centralized power stations. So because of the ease of transmission of electricity, we can set up centralized power stations which can distribute the electrical energy all around. So that is the ease of transmission. Now the next characteristic of electric energy is ease of control and conversion. So if we talk about electricity, it is instantly controllable. Electricity is precisely measurable. Electricity is easily regulated. So like these are like very important characteristics of electricity. We can instantly control electricity. Like we can control the flow of electricity. We can precisely measure. Electricity is precisely measurable, and electricity can be very easily regulated. So if we look into the examples, so we have seed control of motors using power electronics. So using power electronics, we can control the motors. We also have automatic control of lighting and heating, and rapid start and stop of equipment. So because energy like electricity can be easily regulated, we can have rapid start and stop of equipment. We can have automatic control of lighting and heating. So ease of control and conversion is like a very important characteristic of electrical energy. And if we talk about conversion, we already saw in the previous slides that electricity can be very easily converted into other forms of energy like chemical energy, thermal energy, light energy, and we can do the conversion with very high efficiency, often exceeding 90% in modern systems. So electricity can be converted into other forms with very high efficiency, often exceeding 90% in modern systems. So we saw some important characteristics of electrical energy, like it can be very easily generated, ease of generation, ease of transmission. It can very easily be transmitted over long distances like hundreds of kilometers, and ease of control and conversion. And these characteristics of electrical energy makes it the most versatile form of energy. Now we'll look into the next topic of this lecture, that is electricity as a terminal energy form. So first let's try to understand the meaning of terminal energy. What do we mean by terminal energy? So the final usable form of energy delivered to consumers after all conversions. So terminal energy is the final usable form of energy delivered to consumers. So the energy which the consumers receive at their end is the terminal energy. So terminal energy is the final usable form of energy. It's a very important thing. Terminal energy is a usable form of energy. It's a very important point. And it is delivered to consumers after all conversions. Let us try to understand it with an example. Like if we talk about coal, definitely coal is a primary source of energy. Coal has got energy in itself, but coal needs to be processed. So from coal, burning of coal, we can derive thermal energy. And from that thermal energy, we can like rotate some turbines, and that rotation will generate mechanical energy. And that rotation will like it will be like rotating magnet. So electric magnetic induction flux change, there will be change in flux, so electricity will generate. So once again we started with the coal, burning of coal produced thermal energy. That thermal energy was able to rotate magnets, so that rotation is the mechanical energy. And because of that phenomena, like change in magnetic flux, electricity will generate. So we'll get electrical energy or electricity, and this electricity is the terminal energy because end user is getting this electricity. It's a usable form of energy, and we can make use of this electricity wherever we want. We can drive motors, like we can make use of it in industries, we can make use of it in transportation and so on, all that we saw already, etc. So electricity is the terminal energy. It's the final usable form of energy. If we look at one more example, like from oil also, we can generate thermal energy, which can further be converted into mechanical energy and which can ultimately generate electricity and which can be used for other purposes. So electricity is the terminal energy. So electricity is the terminal energy form. It means it's a final usable form of energy. If electricity is there, we can make use of it. Electrical energy, we can make use of it. We can convert it into something useful. So terminal energy. So we can say that electricity is usually the last stage before the energy is actually used. Now we'll discuss the implication for power engineering. So power engineering means engineering of electricity generation. Now since electricity is the terminal energy, it has got some implications. That is what we will discuss now. Since electricity is terminal, all inefficiencies in generation increase its cost. So this is a very important point. See, the idea is that electricity is the end product. So all the inefficiencies in generation process will definitely increase the cost of electricity generation, and hence economic planning becomes very crucial, and also the load management directly affects cost per unit. So the idea is very clear. Economic planning is very important in power engineering because all the inefficiencies in electricity generation processes will certainly increase the cost of electricity generation. Load management will also affect the cost of electricity. And that's why we can say that power plant economics becomes central to national energy policy. So power plant economics plays a very important role when it comes to national energy policy. Now we'll discuss the next topic of this lecture, that is comparison of electricity with other energy carriers. So if we compare electricity with coal, like I'll make a table. So here we'll have aspect, electricity, coal, oil and gas. So we are comparing electricity, coal, oil and gas. So if we consider the aspect of usability, so electricity, instantly we can make use of it because no need for further processing, instant use, and it is clean. But if we talk about coal and oil and gas, like coal, it requires combustion, and in oil also, like s- some form of burning we want, so combustion will be needed, and they are not clean, they can cause pollution. So in terms of usability, it's very clear that electricity we can make use of it instantly, it's clean. But coal and, like coal or oil or gas, if you consider, you cannot use it instantly, you have to first process it, so combustion, and it can cause pollution also. If we talk about control, very precise, like we can control electricity very precisely. For coal, poor control, because the idea is that when the coal is burning, you cannot regulate it, it's like it's out of control, so poor control. And oil and gas also somewhat we can control, especially gas we can control to some extent. If we talk about pollution, so electricity is zero pollution at point use, zero pollution at use point. And for coal the pollution is high, and for oil and gas it is moderate. If we talk about transport aspect, so for electricity we can transport electricity via transmission lines, and ease of transmission we already saw, very easily we can transmit it, ease of transmission is there. For coal we have to have physical transport, and for oil and gas also we need to have physical transport. If we talk about storage, okay, so here comes the catch. Now storage of electricity is difficult, we cannot store large amount of electricity efficiently. But the storage of coal is easy, you can dump huge amount of coal and also huge amount of oil and gas. So the storage of coal, oil, gas is easy, but the storage of electricity is difficult. If we talk about end use efficiency, so electricity very high, because electricity we already saw, it is terminal energy, it is a final usable form of energy. But for coal it is low, and oil gas also low, end use efficiency is low. If we talk about conversion, so we already saw we can very easily convert electricity to other forms, so conversion is easy. But coal, we have limited conversion, and oil and gas also limited. And if we talk about safety, so electricity offers very high safety, because see, everything is like, we see electricity all around, we are able to transmit it hundreds of kilometers, so safety is there. Otherwise, the world would not be so safe. If just look at us, everything around us is like, you will see electricity everywhere around you, and safety aspect is there with electricity. But if with coal, it is risky, risk is there. And what risk? Risk of fire, risk of explosion. With oil and gas also risk is there, risk of fire, risk of explosion. But with electricity, it offers high safety. So we compared electricity with other energy carriers, and we can conclude that with the discussion, we can conclude that electricity emerges as the most refined and user friendly energy carrier. So electricity emerges as the most refined and user friendly energy carrier. So this is a very important aspect of electricity. Now we'll discuss the next topic of this lecture, that is strategic importance of electricity. So definitely we have already seen that electricity is the backbone of modern civilization. So if we look into electricity in industrial growth, so industry requires reliable power, high quality supply, and continuous operation. So industry, they need reliable power, high quality supply, and continuous operation, and electricity enables it. So electricity enables automation in industries. Electricity enables high productivity. Electricity enables advanced manufacturing, and electricity enables precision engineering. So one very important point we can add: industrial output is directly proportional to electricity available. So from here, you can realize the strategic importance of electricity in the industrial growth, because industrial output is directly proportional to electricity available. Now, if we look into the strategic importance of electricity in urbanization, so urban systems depend on electricity for water supply, sewage treatment, transportation, communication, and public lighting. So urban systems depend on electricity for water supply, sewage treatment, transportation, communication, public lighting. So without electricity, modern cities cannot function. That is obvious. So from here we can realize the strategic importance of electricity in urbanization, and also like urban load patterns also shape power plant sizing, and also base load and peak load planning. So urban load patterns, it helps in deciding, it shapes power plant sizing, because if the load is more, the power plant has to be big. And base load and peak load planning. Now we will discuss strategic importance of electricity in deciding the quality of life. So definitely it's obvious that electricity improves healthcare, like hospitals, diagnostics. Electricity improves education, like schools. Just imagine schools without electricity. Very important, electricity. So schools, digital access. Electricity improves domestic comfort, like in our households. This electricity is playing a role, and also communication and entertainment. And electricity consumption per capita, consumption per capita is often used as an indicator of standard of living. So it's a very important point that standard of living is indicated by the electricity consumption. Electricity consumption per capita is often used as an indicator of standard of living. So strategic importance of electricity: electricity defines the quality of life. The consumption of electricity, the more the consumption of electricity, it is assumed that the quality of life is good, the better the quality of life. So we saw the strategic importance of electricity. Now we'll discuss the last topic of this lecture, that is electricity as an indicator of economic development. So the basic idea we already got in the previous slide. Like we saw that consumption of electricity per capita is an indicator of quality of life. So countries with high electricity consumption per capita implies it is a developed economies, and countries with low electricity availability implies developing or underdeveloped regions. So hence we can say that growth in electricity demand, growth in electricity demand reflects economic growth. Power planning becomes a national priority. So from all this discussion, it makes sense that electricity is an indicator of economic development. High electricity consumption per capita directly implies it's a developed economy. Growth in electricity demand reflects economic growth, and hence power planning is a national priority. And that's why it makes sense. Like the module 1 is about economics of power generation. So now it's very clear to us the importance of economics of power generation. And that is what we will be studying in the module 1 of this course. Module 1 of this course is all about analyzing the economics of power generation. So finally, we completed this lecture. So in this lecture, we established that electricity is the most versatile and the most refined form of energy. It is easy to generate, easy to transmit, and easy to convert, and also control. And we saw that electrical energy acts as a terminal energy form. It is the backbone of modern society, modern civilization, like industries, cities, even households, all of that, like all the sectors, almost all the sectors are powered by electricity, and its availability and cost shape economic development. It's an indicator of economic development. So, students, we completed this lecture. I hope you got a very good understanding of about the role of electricity in the modern society. That is what this lecture was about. So, do subscribe to our YouTube channel, Scale Up University, for more such interesting lectures in the course on power plant engineering, and also for other courses as well. So, thanks for watching. Thanks for your time.